Welcome to our class for today. And in today's class, we are looking at chemistry. Let's quickly look at this Jupeb past question. The question says, given the reaction scheme below, these are the reaction scheme given. That is CH2, double bond, CH3, sorry, CH2, CH2, COOH, functional group. This one is called reagent. That means I'm using this one to resolve this one. Our aim is to obtain this X and this Y. So these are another reagents given. This reagent, when we obtain our X, use that X, combine with this one, we get this Y. And let's move quickly. The question says, write the chemical formula and name of X and Y. Write the chemical formula and name of X and Y. So the next one says, give the name of the reactions producing X and Y. Name of reaction producing X and Y. Let's take our solution. So let's take the reaction now. For X, I'm solving part by part. For X, that is CH2 double bond, CH2, COOH, undergoing H2 slash RNI will give me X. I want to obtain this X. Remember, I'm taking part by part. Then I'll combine the overall reaction. So now for X, I told you here that this man is a reagent used to obtain this man. Use this one to obtain this man. That is, here is hydrogen, the is double bond. Remember, this man, the whole of this man is classified under alkenes because of the presence of double bond. This man that you are saying is classified under alkenes because of the presence of double bond. This man is classified under alkenes. So now, it simply means that this is a reduction reaction. This is a reduction reaction. Looking at this, it means we are adding an hydrogen to this man because this man is lacking 2 hydrogen. So once we add this hydrogen into this man, you see this man will result from alkenes to alkenes. This one will result from alkenes to alkenes once we introduce 2 hydrogen inside because here is a reduction reaction. It's simply meant to add 2 hydrogen to this one. So let's see how we can do that. Before you do this, before you introduce hydrogen into this is how to do it. And what you do is that just drop 1 hydrogen here as a base because it is 2 hydrogen molecules. Then drop 1 here on top as a base. So dropping that as a base, it simply means that at this point, I'm taking this man to this man. That this hydrogen will enter this man, and then this other hydrogen is entering this man. That hydrogen, this other hydrogen is entering this man. So if this man is entering this man is entering this man, if you look at that, the equation is the molecule is actually balanced. And at that point, once we introduce this man, obtain this man. So it's telling me that my X is given me I'm using hydrogen, I'm adding hydrogen. That will be CH3 because I've added this man. Then I also added this man. Then single bond CH2, then CH2, then CH2, COOH. Then I have to use the name of this is formula for X because it said write the chemical formula and name of X and Y. This is the chemical formula for X. Then the name of the reaction, name of this guy is the name of X. I want to name this man now. If you look at what I'm doing. I want to name this man. We're going to look at this man. For you to name this man, this functional group, start from the functional group because we always give functional group the smallest possible number. So we start from functional group. So if I'm starting from functional group, that means you will my carbon 1, this is my carbon 2, carbon 3, carbon 4, then carbon 5. It's very important to signify or to identify to denote this number so that you quickly recall your mother name. Remember, when we have 5 carbon atoms, we refer to it as pentane. No, pentane is 5 carbon atoms. Yes, pentane is 5 carbon atoms. So now, when you are naming this with respect to the functional group, this functional group is in the COOH. COOH This is carboxylic acid, or you call it alkanoic acid, carboxylic. Carboxylic acid, or you call it alkanoic acid, or you can say alkanoic acid. This functional group. So now, looking at this functional group, it's telling me that here is alkanoid. So naming this, we know that our mother name is pentane. Mother name is pentane. Mother name, 5 carbons atoms give us pentane. 5 carbon atoms give us pentane. So this is a functional group, carboxylic alkanoid. So if you look at this, since 5 carbon atoms give us pentane, for me to name this man, I'll quickly erase this E, then put this man, this IOC. I will quickly replace this man, this man with this man. That's this. That's why we talk about prefix and suffix. So if you look at this is my suffix. So I'll quickly replace this man with this man. So naming this, we know that our mother name is pentane. So our name of X is pentanoic acid. This is our name of X, pentanoic acid, because it's pentanoic because everything is a single bond. Arabian, it was a double bond. You could have seen the difference. You see that, notice that here there is a change to C. Here there is a change to E. But now at this point, it's single bond. So we name it as pentanoic acid. So let's quickly get we have done with X. Let's check for Y. Let's get for Y. So that's avoid waste of time. So our question says we are using X to obtain Y. So our X is CH3. CH3, single bond, CH2, COOH, plus, I can use plus or anyone. The other use the arrow or use plus, do the same thing. Plus CH3, CH2, OH. And we have to obtain this man. Y. We have to obtain Y. So now, looking at this, looking at that reaction, this is carboxylic acid. This is alkanoic acid. This is alcohol. This is alcohol. Alkanoic acid plus alcohol will give rise to what? Esters. Remember, addition of carboxylic acid and alcohol give us ester. That is the definition of esterification. That is the formation of carboxylic acid or alkanoic acid plus alcohol give us esterification. So you simply need that when I add this man to this man, I will result to esters. So how do you do that? This is how it goes. For you to obtain esters, this is how we do. What we do is that we eliminate this man. This is what we do. Remove this man with respect to this man. So I've seen what I just did. I remove this man OH as the alcohol at the alcohol. They remove H at the carboxylic acid. So once I remove this man and this man, I will give me a rest of distance. So if I do that, let's see how the reaction will go. So Y, reaction for Y will give us CH3, single bond, CH2, 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 C, OO. Remember, I remove this man and this man. So I quickly take this man inside here. That is this man. I'm taking this CH3, CH2 inside. I'm taking CH3 inside. So that you will have this CH3, CH2 then plus water, that is H2, which is water. So So my people, but our aim of that reaction was based on this man, not this man. But you can still substitute this man. You can still put this man. Yes, you can still put it because it's what you remove from that reaction. It's what you can still put it. It's what you remove. So that means we have gotten our y. Then the next one is the name of y. So at this point, let's look at how I'm going to name this reaction. Look at the way I'm going to name this reaction because I name x, now it's there for me to name y. So name of y. Naming this man. If you look at this is R cube. This is R cube. And the functional groups at the middle. Remember, we consider the longest carbon chain. So if you look at that, if you look at from here with 1, 2, 3, 4, this one is 5. But the name is this one is 1 and 2. So that means this side is the longest side. So that means we will treat this treating this man as our substitute. If this is where I will start our name from here down. This side is my substituent, then I will name from here down. So remember, our 5 carbon atom is what? Is our benzene from here. 5 carbon atom is benzene. Naming this CH3, CH2. Remember, you need to flash your mind back to once you have part number. This is 5 hydrogen. Once you have 5 and you need to flash your mind back to alkene. So at this point, remember CH3 give us ethane. So if I remove one hydrogen, have something like this CH2, CH3, that means I'm having ethyl. So that simply means that this man is ethyl. So I'll name from this man. That simply means I need to put a cleavage here. I'll break that bond. Put a cleavage. Bond cleavage. Bond cleavage simply means breaking of organic matter. So if this man, this cleavage level to name, that means after naming this man, then I'll now come back to this man. So if I name this man, I'll have ethyl, then I'll come back to this man. If I tell you 5 carbon atom is 20, so that will give me benzene. Functional group. Esters can also be called alkanoids. Either you call it esters or you call it alkanoids. In terms of their name, we use alkanoids. So we use glues. So at this point, because here is 5 carbon atom, that will give us pentanoids. Then our words. Here is our name for y. Name of y is pentanoid. Then the next question says, give the name of the reaction producing X and Y. Name of reaction producing X and Y. So name of reaction producing X and Y. So at X, if you look at the X, what do we do? If we're introducing hydrogen into the molecule, we're adding hydrogen inside. So what does that mean? That means addition of hydrogen. So that means at the X, name of the reaction is additional reaction. That is for X. Then for Y, if you look at Y, what we do at Y, I remove this man, we get my Y. What does it mean? That simply means elimination reaction and eliminating with respect to H. You get my Y. So here is the elimination reaction. Once this question is given, follow this method. This is the step for you to solve this question. This has come to the climax for today in this particular class. Yes, this will be out because that's the question. The last question is give the name of the reaction using what? X and Y. So these are the names of the reaction that produce X and Y. So this addition reaction produce X, then while the elimination reaction produce what? Y. Because at the one having a removal of H and OH. Then at this point, we are having addition of hydrogen into that particular. So thank you very much. Stay informed so that in our next class we can check more of